prove that the sequence is bounded and monotonic, then you can get that it converges, even if you can't actually find the formula. So what do you guys think? Is there an easier way to prove that this thing goes to 0, or to at least see? Suppose let's set aside proof for a second, and let's just talk about sort of more off-the-cuff calculations. How would you, if you're just after an answer, a yes or no answer, all right, and you didn't have to justify your work, how would you attack such a problem? Supposing you knew what factorial meant. Unjust version. So I guess what I would think about, yeah. Limits within, but I don't know how to integrate, like, I don't know the continuous extension of the factorial. Right, like last time we had something like n e to the minus n. So we're like, oh, okay, f of x equals x e to the minus x, and we're off and running, right? But we're stuck here because we don't know what is x factorial. Like, what's 0.5 factorial? Does this have a meaning? Yes. It does, but you don't know about it, so it doesn't have meaning to you. All right, fine. That's another story for another day. If you look into something called the gamma function, there is a meaning to factorial. But you don't know that, right? So that's not allowed. How about this? This is 2 to the n over n times n minus 1 times n minus 2, 3 times 2 times 1. I mean, does that help? I'm not sure that really helps. I mean, if I could, okay, there's a squeeze theorem is what I'm trying to get at, guys. You know, if you can find L sub n less than or equal to A sub n less than or equal to U sub n, like a lower and an upper bounding sequence, right? And if you have L sub n and U sub n both going to 0 as n goes to infinity, then squeeze theorem says what? Provides the limit as n goes to infinity of A sub n, whatever it is 0, right? So that's a technique that maybe that has hope here, because clearly 0 is a good candidate for my L sub n. The question is, can I bound this? And I don't know. I'm just posing this as a question. It maybe it's not easy to do that here. Could we find a sequence that's above that and goes to 0 and use the squeeze theorem to show that this goes to 0? What's the rule? I need to make the denominator what? Smaller? To make the fraction larger, in principle? And so, of course, you could do something like replace n factorial with n, right? Is n factorial greater than n? It's greater than or equal to n for n. Certainly that's true for n greater or equal to 1, right? But does that help you? It doesn't really help you. Why? Because then that would suggest that the u sub n, I mean, we have this, right? And the reason that's not helpful is 2 to the n over n. Now we can go back to your technique. We can look at 2 to the x over x, right? And use L'Hopital's rule there, right? Extending n continuously, what's this go to? Natural log of 2 to the n, divided by 1. And what does that tell us? This goes to infinity. So hey, we found something bigger than our sequence, which goes to infinity, which tells you nothing really, right? So maybe it's hard to actually justify that 2 to the n over n factorial goes to 0 carefully. I mean, you can start plugging in numbers, right? If you start plugging in numbers and you play with it a bit, you'll be convinced that it goes to 0 after you calculate about 10 of them. Maybe 5 or 6, maybe even will be enough, right? But both 2 to the n and n factorial are getting large, right? So there's some kind of battle that has to be fought here. We found an, I think, unambiguous answer that it goes to 0 through relatively no jumping using the bounded monotonic sequence theorem. So, all right, moving along here. What are the other ways we can show a sequence is increasing or decreasing? If the formula is something that has a nice continuous extension where we can do calculus, then we can just do what? I guess some example 8. If we have like a sub n is, I don't know, inverse tangent. Well, I think you guys could tell me what this one does, right? But what if I did divided by n? You know, is this an increasing or decreasing sequence? What's the story? And you know, it's possible that it's neither increasing nor decreasing, right? You could have the situation where the sequence increases to start with and then it decreases later, right? In such a case, we'd kind of like to split off the initial finite increasing piece and think about it separately and look at the tail which decreases as 2 separate problems or something. Okay, so here I would suggest we look at f of x equal to inverse tangent of x over x, right? And then what's df dx? Oh, yowzers. I regret my life. I made some poor choices here. This is not a good example. I was trying to find something that we could look at and see whether the derivative was positive or negative, right? I have veered into an example which would require some somewhat careful analysis to figure out what happens. I will foolishly forge ahead and try to say something. 1 plus x squared minus inverse tangent of x over x, right? Surely this is positive for x greater than or equal to 1, right? And how about inverse tangent of x? I mean, here, I'm not sure what happens with that. It's at least non-zero. I mean, it's at least well-defined, right, for x greater than or equal to 1. Remember, inverse tangent looks like what? Pi over 2 and x looks like this. So I think that is what? I mean, it's clear to me that x is greater than or equal to inverse tangent of x for x greater than or equal to 1 from thinking about the graphs. But man, I still have that 1 over 1 plus x squared, which is also what? Smaller than 1. The question, which one of these is, I don't know. No, I don't know. I'm sorry, this one's just too hard to do on the fly. My bad. So I guess not a test question, right? Example 9. How about this one? You know, this sequence, is it increasing? Is it decreasing? How would you deal with the sequence? So what I would do is I would look at this as n squared over e to the n, right? And I would apply L'Hopital's rule, extend n continuously. So I can use L'Hopital's rule. And what would that give me? So we get this limit converges to what? So this example actually worked out a little bit more nice. So I guess my question would be, is this sequence increasing, decreasing? What do you guys think? What are the terms in this sequence, actually? I've got, what, 1 over e, 2 over e squared, not 2, but 4 over e squared, 9 over e cubed, 16 over e to the 4th, in fact, we should be able to prove that this sequence is what? It's decreasing, right? This is a decreasing sequence. And one way you could do that would be to look at f of x equal to x squared e to the minus x, right? df dx would be what? So if you look at df dx, you get x times 2 minus x times e to the minus x. And if you make a sign chart for the derivative here, you've got zeros at 0 and 2. If you plug in like 1, you get positive, and then you get negative. So it's a kind of funny thing. This sequence is actually what? Is this sequence decreasing? Is it increasing? It's actually neither, because we have a sub 1 is less than a sub 2, right? But then a sub 2 is greater than a sub 3, is greater than a sub 4. In other words, the sequence starts decreasing at 2 and beyond, but it does increasing going from 1 to 2. And you can kind of see why that is if you look at the derivative of the continuous extension of the sequence. But again, to find the limit here, we should just use the L'Hopital's rule. I'm sorry, I seem to have gone over. Tomorrow, I will talk about limit properties and do some proofs from the epsilon definition. So.